Welcome to this explainer. Today we're going to literally peel back the layers of artificial intelligence, kind of like a Russian nesting doll, to see how the magic actually works. I am so excited to guide you through this. There's so much buzz around AI right now, but behind all the hype, there's actual understandable logic. And our goal today, we're going to completely demystify that logic.
Okay, let's just dive right into our roadmap. We've got 5 main sections to cover today. Everyday AI explained, the machine learning engine, 3 paths of learning, the deep learning brain, and finally, generative AI and LLMs. Let's get to it.
Kicking things off with Section 1, Everyday AI Explained, or why you are already a power user. A lot of folks still think artificial intelligence is just, futuristic sci-fi or complex robotics. But the truth is, it's already right there in our pockets. So I want you to honestly ask yourself this question before you assume you don't know anything about how this tech works. How much AI have you already used today? Think about your morning routine, your commute, or even how you navigated the internet just to get to this explainer. Seriously, if you've done any of these things today, you are already constantly interacting with human-like machine intelligence. Unlocking your phone, that uses computer vision to map your face. Asking Siri for the weather relies on natural language processing and speech recognition. Netflix and Amazon use recommendation systems to learn your tastes, and Google Maps uses predictive AI to estimate your arrival time with stunning accuracy. See, you're already an AI power user.
Moving on to Section 2, the machine learning engine. This is the core driving force of modern AI.
The really crucial point here is that once the internet gave companies literally endless amounts of data, we had to completely shift our approach to computer science. Instead of trying to write endless lines of human code to cover every single possibility, which is impossible by the way, we decided to just let machines learn from that massive pool of data directly.
And this right here represents a massive paradigm shift. In traditional computer science, a programmer writes the rules, write the logic. You feed the computer an input, it applies your rules, and it spits out an output. But in machine learning, we totally flip the equation. We give the computer the raw data inputs, and we give it the correct historical outputs, and then we ask the computer to figure out the logic on its own. That generated logic is exactly what we call a machine learning model.
Which brings us to Section 3, 3 paths of learning, or how the machine actually learns.
So we know the engine learns from data to create these models, but how exactly does it study? Well, there are 3 distinct ways. First up is supervised learning, where the machine is guided by perfectly labeled data. Think of a bank looking at thousands of past loan applications to predict if a new one should be approved. The historical data clearly says approved or rejected. It's completely labeled. Second is unsupervised learning. Here, the machine gets raw, unlabeled data and just finds hidden clusters on its own. Imagine handing a machine thousands of random news articles. It naturally groups the tech articles together, the sports together, and the politics together, just by finding those underlying patterns. And finally, reinforcement learning. This is literally like training a dog. The machine operates in an environment, making guesses. If it makes a good move, like climbing a ladder in a video game, it gets a digital treat, a reward. If it hits a snake, it gets a penalty. Through pure trial and error, it learns the perfect strategy to maximize its rewards.
All right, let's go deeper. Section 4, the deep learning brain. This is all about neural networks and dealing with unstructured data.
Peeling back another layer of our Russian nesting doll, we reach a highly specialized subset called deep learning. This is super vital because standard machine learning is great for neat rows and columns of data, like bank records. But to process a YouTube video, a flowing text file, or a high-res image without human intervention, computer scientists realized they had to digitally mimic the biological structure of the human brain. So we built artificial neural networks, complete with an input layer, an output layer, and multiple hidden layers of interconnected neurons sandwiched right in between.
To really grasp how these networks learn, think of a neural network like a college grading system. The college wants students to actually attend class, right? So, step 1, the teachers assign an initial weight to tests. Say midterms are worth 40% and pop quizzes are worth 10%. Step 2, they look at the outcome. Turns out students are still skipping class because the quizzes just don't matter enough. So, step 3, the teachers adjust the weights. They lower the midterm to 30% and raise the quiz to 30%. They basically tweak the system until they get the exact outcome they want. Neural networks do the exact same thing, but with data.
In technical terms, this is a 2-step dance. Step 1 is forward propagation. The data moves forward through the layers of neurons, applying mathematical weights, and the network makes a calculated guess. Step 2 is backward propagation. The network checks its guess against the correct answer, calculates its margin of error using what's called a loss function, and then propagates backward through the network. It adjusts the weights and biases of every single neuron so its next guess will be more accurate. It literally learns from its mistakes.
But we hit a massive wall when it comes to visual data. 3 million. That number right there represents the 3 million separate data points a single neuron would have to compute just to look at one basic 1,000 by 1,000 pixel colored image. That's 1 million pixels multiplied by 3 color channels, red, green, and blue. Feeding this directly into a standard neural network would cause total system overload. It would require an impossible amount of computing power.
Because processing millions of pixels all at once is just impossible, scientists created a specialized architecture called convolutional neural networks, or CNNs for short. Instead of looking at the whole image instantly, a CNN uses a kernel to scan small patches of an image. It finds corners, edges, and shapes one tiny chunk at a time. This drastically reduces the computational load and makes things like automated traffic cameras and facial recognition actually possible in the real world.
And just as CNNs completely revolutionized how machines see, we needed a breakthrough for how machines read. Older networks struggled with long text because they read word by word, often forgetting the beginning of a sentence by the time they reached the end. So we built transformers. Transformers view the entire sequence of data all at once. They use this brilliant mathematical process called an attention mechanism to score how words relate to each other. If I say, the dog chased the cat because it was scared, the transformer's attention mechanism instantly calculates that the word it likely refers to the cat, grasping the true context and meaning of human language. It's a real game changer.
Finally, Section 5, Generative AI and LLMs, the absolute center of the nesting doll.
This brings us to the core of our explainer. Let's dive into this final paradigm shift, because this is honestly what changed everything. Past AI analyzed data. It told you if a photo was a cat or a dog. It told you if an email was spam or not. It found patterns. But generative AI uses those deeply learned patterns to create entirely new data from scratch. It generates new text, new audio, new images, and new code that has literally never existed before.
Powered by natural language processing and large language models, which, by the way, are transformer networks trained on billions of parameters across vast swaths of the internet, these are the tools revolutionizing our workflows today. ChatGPT and Gemini can write your emails and essays. Midjourney and DALL-E can render breathtaking original artwork. Sora can generate hyper-realistic video from a simple text prompt. And GitHub Copilot is out there actively helping developers write complex software code. They aren't just searching for answers anymore, they are generating them.
So, we've unpacked the entire AI nesting doll together today. From everyday algorithms to the machine learning engine, right down to the deep learning neural networks and the generative magic they power. I want to leave you with this final thought. You are no longer just a passive user. Now that the magic is demystified and you actually understand the logic beneath the hood, what will you build with it tomorrow?